Taking a look at 8.3, 8.3 really is the converse to everything we learned in 8.2, which means that now we are trying to show reasons why your shape may be a parallelogram as opposed to properties of it. For example, in the opener here, we know one of the properties we learned yesterday is opposite sides do have to be congruent. So I got the 14 with the 14, so I do have my opposite sides congruent here. Now, some people I should say, will look and say, well, my other set of opposite sides are congruent because I got 8, and if x is 4, then they're going to have to be equal. Well, there is nothing here saying x has to be 4. As a matter of fact, one of the other properties we know about a parallelogram is these consecutive interior angles need to add to 180. When I add these together, though, we get 190 degrees. So this is not going to work to make a parallelogram. All right, and that's what we're going to get into today is those properties that we can use to show you have a parallelogram. All right, so our first one here. If both pairs of opposite sides are congruent, then your quadrilateral is a parallelogram. So you do need, as we showed in the opener, you do need both pairs of opposite sides to be congruent, not just one set. Second way we can talk about it, we can talk about those opposite angles as well. If, once again, both pairs of opposite angles are congruent, then your quadrilateral is a parallelogram. Now, if you need more time for a definition, please just pause the video to finish copying it down. All right, taking a look at our example, it says in the diagram, it says AB and DC represent adjustable supports of a basketball hoop. It says explain why AD is always parallel to BC. Well, if you look at the measurements that are here, right, this support bracket that's here, the 36 inches and the 36 inches, they will never change the lengths, no matter how you have that hoop set up. They're metal brackets. Likewise, the AD and the BC, the 18 inches that are there, they will never change their lengths either. So, in that figure, it's always a parallelogram since those opposite sides are always going to be congruent. As soon as I know it's a parallelogram then, all of my other properties that we learned yesterday will have to hold true also. In specific, in this problem, AD and BC are opposite sides, so they are going to have to be parallel as well. Right? The idea here is that if you can show that if you can prove that you have a parallelogram, then all of those properties you learned in 8.2 will have to be true, even if they're not marked in your picture. Right? Other ways to show that you have a parallelogram. We can look at one pair of opposite sides. We actually don't need both pair. However, that one set we look at will have to be both congruent and parallel. So that same set will have to have the same length, and it'll have to have the same slope to it. So that they are both congruent and parallel to each other. Now the final way we can show it is to show that those diagonals bisect each other. Right, so those diagonals would have to cut each other in half. So in our next example, it says the headlights of a car have the shape shown below. It says explain how we know that angle B will be congruent to angle D. So we start by showing what shape it is. Now, ABCD is going to be a parallelogram. And the reason it is, if I look at my markings here, I have one set of sides being both parallel and congruent. So B, C, and AD are congruent, and they are parallel. Once you show that you have a parallelogram, all those properties, such as opposite angles being congruent, will also have to be true. Now, overall, there are 5 ways to show that you have a parallelogram. They are all here on a chart for you. Oh, I'm sorry. That comes up in a couple minutes. Sorry about that. Take a look at the next example. It says, in quadrilateral GHJK, it says the measure of angle G is 55 degrees, H is 125, J is 55. It says find the measurement of angle K. If I look here, I have my quadrilateral. This is how I labeled it. Remember, it is just a quadrilateral. We don't know anything else about it. Angle G is 55. Angle H is 125. Angle J is 55. Angle K is what we want to find. They do not tell me this is a parallelogram, so I cannot automatically assume that both pairs of opposite angles are equal. The only thing we actually do know is these angles have to add up to 360 degrees. So 125 plus 55 plus x plus 55 will have to equal 360 degrees. So when I add these together, 125, 55, and 55, when we combine those, we get 235 plus x equals 360 degrees. When I subtract it over, I actually do get the 125 degrees for angle K. So this actually would be a parallelogram then, because both sets of opposite angles are congruent. All right, let's take a look at the next one. It says, for what value of x is quadrilateral PQRS a parallelogram? Now, in order for this to be a parallelogram, the diagonals have to bisect each other, meaning QT has to be equal to TS, which they do have marked. Likewise, PT will have to be equal to TR, which means that this 5x will have to equal 2x plus 9. So to solve our equation, we subtract 2x from both sides. So 3x equals 9, and then we divide by 3. We get x to equal 3. Now, as I was saying before, there are 5 ways to show you have a parallelogram. They are all here in your chart. Option 1, the very definition of it. You can show that both pairs of opposite sides are parallel. Now, one of the problems you're going to see coming up here is going to give you points. In order to show that you have opposite sides being parallel, you need to show that the opposite sides have the same slope. So you're going to need your slope formula. Second way we can talk about it is the opposite sides are congruent, meaning that the opposite sides have the same lengths. So if I give you the points of those sides, which we're going to do here in an upcoming example, we're going to have to use the distance formula to find those lengths of those sides. Option 3, both pairs of opposite angles are congruent. Now, if I give you points, there's really no way for me to go through and find the measurements of those angles. So they have to actually be given to you. Option 4, one pair of opposite sides are both congruent and parallel, meaning one set of sides you're going to have to find the lengths to be the same, so you need the distance formula, and the slopes to be the same, because they'll have to be parallel. Now, your final way to show you have a parallelogram, the last option, is to show the diagonals bisect each other. To show that, you show that they have the same midpoint. If two diagonals bisect each other, they must have the same midpoint. So that's the third formula you will need, is your midpoint formula. Right? If you need any of those formulas, I have them here for you. here are all three of your formulas: your midpoint formula, your slope formula, and your distance formula. Once again, if you need time to copy any of those formulas down because you do not have them, please pause the video so you can get them copied down. All right, let's take a look then. In example 4, it says show quadrilateral KLMN is a parallelogram. Option 1, it says find the slopes of the opposite sides. Then it says why. Why do we care about the slopes? Because they will tell us if our opposite sides are parallel or not. So in this example, to show that we have parallel sides, we are looking at lines KL and NM. They would have to have the same slope. Likewise, KN and LM would have to have the same slope. Now, option 1, you can plug your points into your slope formula, which is right here. Option 2, you can count, rise over run. So if I look at my example, we're going to count. For KL, I go rise of 2, run of 2. So it is 2 over 2, which is 1. NM, rise of 2, run of 2. 2 over 2, so I have a slope of 1. So KL is parallel to NM. We do the same thing then for KN and LN. For KN, I go down 1, 2, 3, 4, so it would be a negative 4. I go right 2, 1, 2, so it's a positive 2. Negative 4 over positive 2 gives me a slope of negative 2. For LM, we go down 1, 2, 3, 4. We go right 1, 2. So it's a negative 4 over positive 2 again. Which gives me a slope of negative 2 as well. So both sets of opposite sides are parallel. The second part of this says to find the distance of the opposite sides. Why do we care about those lengths? We want to tell if the opposite sides are congruent. So once again, we want to find the lengths of KL and NM. Likewise, we want to find the lengths of KN and LM. Now, you have two options here. Option 1, you can plug your points into your distance formula, which is right here. Plug your x's in, plug your y's in. However, I've gone over a shortcut a few different times this year. I'm going to review it right now, and this is why I created this shortcut and talk about this shortcut. We've already found the slopes here. We found this slope here, and we found it here. We can use these unreduced slopes to find the lengths. For LKL, all I'm going to do is 2 squared plus 2 squared and throw them under the square root symbol. 2 squared is 4 plus 2 squared, which is 4. We get the square root of 8. For NM, I have 2 squared, which is 4, 2 squared, which is 4. We have the square root of 8 also. For KN, I do negative 4 squared, which is 16, plus 2 squared, which is 4, so I get the square root of 20. Negative 4 squared is still 16, 2 squared is still 4. We still get the square root of 20. Right? That's how you can use that unreduced slope to find your lengths. Now the last question says, is there another way to solve example 4? Is there another way to show that this is a parallelogram? The last option we have is we can show the diagonals bisect each other. Meaning we will need the midpoints. We will need the midpoints. We will need the midpoints of our diagonal. Sorry, having a little difficulty there. We need the midpoints of our diagonals. If I go up and look at my figure, my two diagonals, one diagonal would be LN. So if I come down finding that diagonal LN, my midpoint formula says we add our x's and divide by 2. We add our y's and divide by 2. So my x's are 4 and 4. My y's are 4 and negative 2. So I'm going to do 4 plus 4 divided by 2. 4 plus negative 2 divided by 2. So we are going to get 4, 1. There's my midpoint of Ln. We also need the midpoint of Km. So I have 2 plus 6 divided by 2 and 2 plus 0 divided by 2. So it's 2 plus 6 divided by 2 and 2 plus 0 divided by 2. We get 4, 1. So those diagonals do have the same midpoint. That's how you show that they would bisect each other. Leads us to our last problem here. It says, for what value of x is quadrilateral DFGH a parallelogram? So once again, our diagonals have to bisect each other. So the 4x minus 7 has to be equal to the 2x. (4x minus 7 has to be equal to my 2x. So we'll subtract 2x from both sides. Have 2x minus 7 equals 0. We'll add 7 to both sides, so 2x equals 7. And then we divide both sides by 2. So x equals 3.5. Leads us to our homework here tonight. Pages 526 to 527. Numbers 4 to 28, the evens. If you have questions on anything, please make sure you ask.